Hey, discrete math students. Welcome to this extra example video. In this video, we're going to build a truth table for a formula with 3 variables. So, by the time you are ready for this video, you should have already learned the truth tables for the 6 basic connectives. Once you know those basic tables, you are then ready to start building truth tables for larger formulas that involve multiple connectives. So for this example, we're going to make a truth table for the formula not quantity P and Q or not R. Okay, so before we delve into the bowels of making this truth table, let's make sure that we set up the truth table properly. Okay. And a table, of course, is going to have rows and columns. So first of all, see if you know the answer to this question. How many rows will this truth table have? If you want, you can pause the video to see if you can answer that. Okay, let's start by making our rows. We have a larger screen here where we can fit this whole truth table, which will be relatively large. Now we have 3 variables in this formula, P, Q, and R. And so we know that we are going to have a column for each of those variables. Okay, hopefully you knew that this truth table is going to have 8 rows. And according to standard conventions, which will be the conventions in our class mathematically, for mathematical purposes, we always put our trues as close to the top as we can, starting on the left. So we're going to have 4 rows where P is true and 4 rows where P is false. And so we put those 4 rows where P is, for P being true, at the top of the table, and then the bottom 4 rows are the rows where P will be false. Okay, going to Q now. Again, when P is true, Q can be either true or false. We want to put our trues toward the top. So we'll have 2 trues for Q there, and then 2 falses. Okay, now when P is false, again, Q can be true or false. We want the P's further toward, or the T's further toward the top on that. So we have true, true, false, false for the bottom half of Q, the Q values. Then for R, well, for each combination of P and Q, R can be either true or false. And again, in each of those scenarios, we want the T above the F. So we have true, false, true, false, true, false, true, false. Try to line everything up here as nicely as possible, and that seemed to go pretty well. Okay, so we've got our 8 rows set up, and we already have 3 columns. One question might be, how many more columns are we going to get? So, to think about that, we look at how many connectives we have. Since we put in all the details in our table, and we don't omit any columns, we will have a column for each connective. So each connective either combines 2 previous columns or modifies 1 previous column. So you can think about how many more columns we are going to get than what we already have. I'll give you a second to think about that if you like. You can pause if you want. All right, so let's put our columns in now. Okay, so first thing that we see here is we have a conjunction, P and Q. So we can do that first, and that is inside parentheses, which is one good reason to do it first. We certainly have to do it before this negation that is outside the parentheses. Once we do P and Q, the parentheses say we're going to negate that whole thing. So we're going to have the negation of P and Q there. Now we also have a negation on our R. So let's put negation of R in here as a column. Now, truth be told, you could have done the negation of R first, before P and Q and not P and Q. And then finally we get our last column in here, which is combining the whole thing all together. And so we put together our negation of P and Q, disjunct that with not R, and that will be the final column of our table. Okay, now one other interesting thing to think about here is to see what is the main connective in our... Sorry, I'm a bit under the weather here and have to keep stopping to cough. Anyway, another interesting thing to think about is what's the main connective in our formula? That will be the connective that is evaluated last in determining the truth values of the overall formula. And that indicates the type of statement mainly that you're dealing with. Of course, it has various connectives, but overall it is mainly one type of statement. So see if you can think about, or as we look back at our table and so on and finish constructing it, see if you can determine what is the main connective in our formula, what type of formula it thus is. All right, let's fill in our values here. Okay, P and Q. Well, we know that for that to be true, both P and Q must be true, otherwise it's false. Well, in the top two rows, those are the rows where P and Q are both true, so it's true in those. And in the remaining 6 rows, there's always at least one of P and Q that is false, so we'll get falses for those. 6 falses. Again, trying to keep things lined up, doing a halfway decent job. Okay, next column, we have the negation of P and Q. Well, we just did P and Q in the previous column. We're now going to negate that, which means we switch all the truth values that we had. So that's going to start with 2 falses, and then the rest will be flipped from false so that they are now true. Okay, third column, we have the negation of R. Same kind of idea there. We look at the R column, our third column on the left, and we just flip all the truth values we had for that. So negating R will give us false, true, false, true, false, true, false, true. Okay, and then for our finale here, we're going to put everything together. We're going to do the disjunction of the negation of P and Q, which was 2 columns previous, with the negation of R, which we just did. So for a disjunction, as we know from its truth table, this is inclusive disjunction. So as long as one of those 2 components is true, then the value will be true. But if both of them are false, our overall value will be false. In the first row, we do see that actually both of our components are false there, so we're going to get a false up top. But if you look the rest of the way down, I mean, for instance, in row 2, we have a false and a true. Disjunction of those is going to be true. Then we have a true and a false. Disjunction of those is true. And actually, all the rest of the way down, we have at least one true. If both are true, that's fine as well, as they were in row 4. So the rest of the outcomes will be true. So overall, we have truth values for our formula of false, true, 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 true. And again, it really is unambiguous to say it that way, as long as we're using the standard setup for our table of having all of the truths as close to the top for our variables moving left to right. So it definitely is important to preserve that order. Well, did you figure out what type of statement we have here, or what type of formula? The last connective that we evaluated was the disjunction right here, and so we could as well say that overall this formula is a disjunction, and it has the truth values as listed there in the right-hand column. So the disjunction is, the inclusive disjunction is the main connective. All right, thanks for watching.